Have you ever just looked up at the night sky and wondered why the universe constantly defies our expectations? I mean, seriously. In this explainer, we're unpacking the sheer, absolute weirdness of the cosmos, from impossible lava worlds to the thrilling hunt for Earth-sized exoplanets, especially the recently discovered Gliese 12b, which has everybody in the astronomy world talking. We're going to dive deep into the mind-blowing cosmic mysteries that scientists are actively uncovering right now. It is a real game changer, for sure.
You know, the famous astrophysicist Brian Cox really hit the nail on the head. He reminds us that the magical spark of life, it's fundamentally just a chemical process. The idea that geochemistry somehow becomes biochemistry, well, it isn't just fanciful sci-fi. It is a proven fact, because it happened right here on Earth. And if the ingredients are the exact same elsewhere, that spark could ignite in places we would never, ever expect.
So, buckle up. Welcome to this explainer, where we are embarking on a mind-bending journey. We're going from the familiar rocks sitting right in our own cosmic backyard all the way to the rule-breaking exoplanets at the very edge of deep space. We'll be charting the chaotic mechanics that might just lead us to another living world.
Okay, let's take a quick look at our flight plan for today. We're going to cover the ingredients for cosmic life, our solar system secrets, how are we writing the planetary rulebooks, a tour of the most bizarre exoplanets, and finally, we'll ask the big one, are we truly alone?
Right, let's jump into part 1, ingredients for cosmic life and building blocks in the deep freeze. So, let's start close to home with asteroid Bennu. This chunk of rock originated in a region of space where temperatures dropped to a bone-chilling minus 400 degrees Fahrenheit. Now, why does that matter? Well, that extreme deep freeze perfectly preserved exceptionally high amounts of life's raw chemical ingredients. By forming in the freezing outermost disk of our early solar system, volatile gases actually accumulated instead of just evaporating away. We are talking water vapor, carbon dioxide, methane, and abundant ammonia. It is literally a frozen cosmic broth just waiting to be thawed out.
Okay, moving on to part 2, our solar system secrets featuring magnetic shields and playground bullies.
Take a look at the stark contrast between Earth and Mars. It's kind of tragic, really. Earth has this constantly churning liquid metal core that generates a massive, powerful magnetic shield around our entire planet. Mars, on the other hand, it was stunted during its formation. Because it's so much smaller, it's heat-cooled and completely solidified. And no hot core means no magnetic field, leaving the entire planet totally exposed to violent solar winds.
And because of that missing magnetic shield, the MAVEN orbiter confirmed a frankly staggering statistic. Mars is violently stripped of 100 grams of its atmosphere every single second by the solar wind. I mean, just think about that. Over billions of years, that continuous, relentless theft completely transformed Mars from a warm, wet world into the freezing, barren desert we see today. But hey, our own solar system dynamics aren't immune to chaos either. Jupiter basically acts like a massive playground bully. It teams up with Venus to drastically stretch Earth's orbit and alter our climate over these massive timescales. Every 405,000 years, their combined gravity actually elongates our orbit, making our hot weather hotter and our cold weather way colder. Right now, we're sitting in a pretty moderate cycle, but in just 60,000 years, this orbital stretch could plunge us right back into a deep freeze.
Which brings us to part 3, rewriting planetary rulebooks and the impossible discoveries by JWST.
When we zoom out into deep space and look at distant gas giants, scientists are quickly realizing that our previous models of how planets form are just, well, they're fundamentally broken. As one researcher studying these impossible worlds put it, each one is completely rewriting our textbooks. So let's look at one of the biggest rule breakers out there.
Prepare for a pretty staggering sense of scale here. TOI 5205b is an impossibly massive gas giant that orbits an absolute dwarf of a star. To put this in perspective, normally, a Jupiter-like planet orbiting a Sun-like star is kind of like a pea going around a grapefruit. But for TOI 5205b, because its host star is so incredibly tiny, it is much more like a pea going around a lemon.
And here is the truly mind-bending part. A star this tiny, which only possesses about 40% of the mass of our own Sun, somehow managed to form a Jupiter-sized planet with a metal-rich interior. This completely defies current physics and planetary mass limits. The James Webb Space Telescope revealed that its interior is 10 times more metal-rich than its outer atmosphere. This total lack of elemental mixing proves it had to have formed in a way entirely alien to anything in our own solar system.
Let's keep exploring in Part 4, the most bizarre exoplanets, where we'll look at lava balls and rock clouds.
So imagine standing on the surface of TOI 561b. It's an ultra-hot super-Earth exoplanet that is actually twice as old as our Sun. Actually, scratch that, don't imagine standing there, because the surface temperature is a blistering 3,200 degrees Fahrenheit. According to every single rule we thought we knew about physics, at that extreme heat, it should be nothing but a scorched, bare piece of rock. Yet, this world has completely baffled astronomers. At these insane temperatures, it somehow manages to hold on to a thick atmosphere by constantly burping out gases from its molten interior. One side is permanently locked in daylight, operating as a literal global magma ocean. It functions like a wet lava ball, distributing heat through an atmosphere that, mathematically speaking, just shouldn't exist at all.
Now, if you thought Earth's weather was bad, check out WASP-94ab. JWST just gave us our first direct observation of active cloud cycling on this hot Jupiter, and the morning forecast calls for literal rock. I'm not kidding. The mornings are packed with clouds made of vaporized magnesium silicate, which are the exact same minerals found in Earth rocks. But as fierce winds push into the evening side, dynamic temperature changes cause those mineral clouds to completely evaporate, leaving stunningly clear skies for the night side. It's absolutely wild. And things get even stranger when we look at where these complex chemicals actually gather. When JWST peeked inside the moon-forming disk of a baby gas giant called CT-CHA-b, it found 7 distinct carbon-containing molecules, including benzene. But when they looked at the host star's disk, 0. Nothing detectable. This proves that the building blocks for complex chemistry can hyperconcentrate in the exact, localized places where moons are born, entirely separate from the barren environment of their host star.
All of this brings us to Part 5. Are we truly alone? Let's redefine habitability.
After seeing all these impossible extremes, we have to rethink everything. If life is just chemistry, then moons orbiting distant alien worlds blanketed by protective thick hydrogen atmospheres, well, they might just be the perfect long-term laboratories for biology to spark. We don't just have to look for perfectly placed Earth clones. The cosmos might be absolutely teeming with insulated, habitable exomoons that harbor the exact chemical broth we found frozen on asteroid Bennu. So, I want to leave you with this final thought. As we continue to shatter our assumptions, going from vanishing rock clouds to impossible gas giants, and making thrilling new discoveries like the highly anticipated, temperate, Earth-sized exoplanet Gliese 12b, we have to ask ourselves, just how much weirder will the universe get before we finally find our cosmic neighbors? Where else is the chemistry of life hiding? Thanks so much for joining me on this explainer today, and as always, keep your eyes on the stars.